can you talk about the like subgroup analyses and kind of your approach to looking at those? As I understand it, technically, and correct me if I'm wrong, the more subgroup analyses you do, kind of the stricter you are with your interpretation of them, maybe in terms of like p-values and stuff. And we'll get to p-values in a minute. But again, correct me if I'm wrong. And just like, how do you think about subgroup analyses, or is there anything like worth noting for people listening?
Subgroup analyses, you can have some interesting debates about how to approach them, because if you are someone who's going into a study and hoping to find something that is statistically significant, um, that shouldn't be the objective of scientific inquiry, but there are some practical pressures that lead people in that direction. Certainly, if that was your goal, you maximize your likelihood by doing more and more subgroup analyses. And as you kind of chop up a data set into many smaller data sets for these analyses, there's just the sheer number of tests that is increasing that probability of finding something that's statistically significant. But also, you are now creating smaller groups of individuals for these analyses. And generally speaking, as groups get smaller, robustness of the effect estimate that we generate tends to go down. That is very much why there's that pyramid, or upside down funnel shape in a funnel plot. Is as studies get smaller, we do expect more variance in the effect size calculated from one study to the next. There's just more sampling error is the term that's often used. So in order to address some of those concerns, often people will say that they're going to do some type of adjustment for multiplicity, or basically saying, hey, I'm going to basically change the threshold needed for a statistically significant finding, because I'm doing all these additional tests. I need to make the bar a little bit harder to clear that and say this is statistically significant. And that's generally done in hopes of establishing more robustness for the finding and saying, hey, we weren't just like throwing everything at the wall to see what would stick here. We have some fairly stringent standards and wanted to keep to that. Now, you can make good arguments that are very much in favor of doing a bunch of subgroup analyses. You could say, hey, this is a meaningful element of the research question, we have good theoretical reason based on past literature or a strong biological mechanism to indicate that this group should respond different from that one, and we want to test that. That makes all the sense in the world. And sometimes there's practical reasons why practical and theoretical, why you would maybe decide not to make those p-value adjustments to raise that bar for clearing statistical significance. I think that's where you get some really heated debates about kind of the theoretical underpinning for why we even have this threshold and where it should be. And so yeah, that's we can get more into that discussion if you like, but generally speaking, there's kind of two camps, right? There's some people who say, if you're going to be doing all these different comparisons and subgroups, you need to raise that bar for clearing statistical significance, because it's very bad if you find some spurious relationship that's not genuinely true at the population level, and you start reporting this all over town, and you're causing all this fanfare and excitement over something that's not a legitimate finding. On the other hand, it's important to recognize that missing significant outcomes is not a good thing either, right? So there is a give and take. There's a trade-off where if you decided, different fields are different. Sometimes people test for a p-value at 0.05 or an alpha level at 0.05. In other fields, there are certain tests where you might do 0.1 in some cases, and there's certainly in physics and engineering, you're going a lot of zeros before you get to any digits. So those are always interesting debates to be involved with, and it's very simple. It's what is the cost of identifying or flagging an important effect that is not actually true, And also,